Section 10x7 polar coordinates. Today we're going to level up, show you a better way, in my opinion, to graph equations on a polar coordinate grid. So polar coordinates, instead of x and y for horizontal and vertical, we need r and theta. Theta is the direction, r is how far in that direction. So to form the polar coordinate system, you start with a point called O, called the pole that is analogous to the origin in the rectangular coordinate system. And then from O, construct a ray horizontally, to the right, not to the left, to the right. Call that the polar axis. That's kind of where everything is going to start, okay? From that polar axis, you create theta. You kind of bring that initial side away from the terminal side. Yep, bring the terminal side away from the initial side, like we saw in chapter 4. And that theta is your directed angle. So it's directed. It tells you which way. It can be positive or negative. And then you have r, a directed distance from your origin to your point. So your point is r comma theta. Is r how far you're going, theta what direction are you going that far. So I get this lovely circle graph with concentric circles all out. Those circles are your radius markers. And the theta measures you may remember from chapter 4, the unit circle. Although here we have the over 12 measured 2, just for some more consistency with the angles and so we can do more. So to graph the point 2 comma pi over 3. So starting from the polar axis, you're going to go 0 degrees up to pi over 3. So one more. So that's theta. Then our r value is 2. So I went on the second circle, the second radius. And we'll plot a point right there. And that'll be point A. Alright? Let's look at point B. Get a different color here, blue. So we're going to be in the third concentric circle. We're going to go negative pi over 6. So we're going to drop down from the polar axis. So the third circle, drop down pi over 6, down to 11 pi over 6. So drop down there. And that's point B. Go, yeah. Do I have? Ooh, I do have a. My dad, when we were younger, he painted our front door, and we saw it. We're like, what the heck is that color? He said, well, it's fuchsia. We're like, Dad, that's pink. So, point C, we'll use fuchsia, okay? So 3 comma 11 pi over 6. So the third circle, 11 pi over 6 in the counterclockwise direction. So up, around, kind of taking the scenic route to the same point, point B. Alright, so 2 different ways to get to the same location. And we'll put in another one here. We'll put in negative 4 comma pi over 4. Alright? So, have a negative radius value. So pi over 4 going that direction. So going that direction. But we're going to go negative 4 in that direction. Okay? So the negative 4, you're going to go away from it. Remember, it's right here. R is a directed distance. So negative 4, go 4 units away from pi over 4. So go down, let's see, 1, 2, 3, 4. My red point, I'll call that D. Alright, so your angle can be negative, or your radius can be negative. If the radius is negative, go away from the angle that you have specified. So if there are polar coordinate systems, just like parametrics, we can convert from one to the other. So we have some equations here, and I want to kind of make a specifying point. These are if you're going to this, what's the word I want? To this form. So equations, as there are conversions for equations and coordinates. So for example, let's look at the polar coordinates. We're going to polar form. That means you're in rectangular form. You have an x and a y. So here going x comma y to r comma theta. X and y, do inverse tangent of those, gives you your theta value. Little Pythagorean theorem, square root x squared plus y squared, gets you your r value. Then rectangular, if you're going to rectangular form, means you have polar form, r and theta. So r and theta going to x comma y. So if you have r and theta, r times sine of theta gives you y, r times cosine of theta gives you x. So converting each point to rectangular coordinates. So that means 2 is r and pi is theta. Now y equals r times sine of theta. So r is 2, theta is pi, sine of pi, so the y value at pi, 0. So y value is 0. To find x is r times cosine of theta. So plug that in, 2 times cosine of pi. The pi, the x value of pi is -1. So 2 times -1 or -2. So then put these together. You get an ordered pair of -2 comma 0. Now convert each point to polar coordinates. So going to polar. So we're looking at these equations right here. We have x and y. We're going to r and theta. So we want that r and theta conversions. So we have x and y. to go to r is the square root of x squared plus y squared. So that would be root 8. Simplest radical form, 2 root 2. To get theta, theta is inverse tangent of y divided by x, so 2 over 2. Inverse tangent of 1 is pi over 4. So putting these together, r comma theta. So 2 root 2 units in the direction of pi over 4. Converting equations is pretty nice. Going each polar equation to rectangular or vice versa. So r equals 2 is a polar form of an equation. So going to rectangular, we have r is r squared equals x squared plus y squared. So x squared, sorry, I don't want that color, let's go black. X squared plus y squared equals r squared, or 2 squared. So we have the equation of a circle, x squared plus y squared equals 4. This graph, if you graphed it in a polar equation coordinate system, your calculator can do that. It would graph a circle with a radius of 2. R equals 2. Doesn't matter what that is, r equals 2. This rectangular is the same thing. It's an equation of a circle with a radius of 2, centered at the origin. Theta equals pi over 6, so our direction pi over 3. I said 6, meant 3. Theta is pi over 3, doesn't matter what the radius is, just always pi over 3. So tangent of our theta value equals y over x, using this right here. Tangent of theta equals y over x. So tangent of pi over 3 is root 3, nope, just root 3, equals y over x. Multiply x over y equals root 3 times x. So a line with a slope of root 3. And that would give us any point in the direction of pi over 3, positive or negative, going up towards it, going down away from it. So take a look at the rest of those. Check your work with my completed notes online.